Hello student, I am S.R.SHIRSATH. Today we are going to see the problems on chapter 1st, Physics of Atom. Before solving the problem, first thing we remember that read problem carefully. And after that decide what is given and what is to be found out. Okay, the first problem, the energy of an electron in ground state of hydrogen atom is minus 13.6 electron volt. Calculate its kinetic energy and potential energy in the same state. This is actually the problem. For a hydrogen atom, ground state means the first orbit, means what is given. For first orbit, n is equal to 1 and the energy of the first orbit is given, and that energy is total energy, that must be equal to total energy of the first orbit minus 13.6 electron volt. Next, calculate its kinetic energy and potential energy in the same state. Same state means in the ground state. Therefore, kinetic energy in the first state we want to find out, as well as potential energy in the same state find out. Okay, first orbit n is equal to 1, total energy is given, and we want to find the kinetic energy and potential energy. For finding this, we know the formula for total energy in nth orbit. Formula for that, we know energy in nth orbit is equal to minus m e raised to 4, there is epsilon 0 square h square n square. This is formula for the energy of an electron in the nth orbit. Means in addition to this, that is 8 epsilon 0 square h square n square. But for the first orbit, means total energy in the first orbit is equal to minus m e raised to 4. For first orbit, find out the value of n is equal to 1, means n square is 1. Total energy is equal to 8 epsilon 0 square h square, and that value is given, that is minus 13.6 electron volt. This is the value of the total energy. We want to find the kinetic energy. The formula for kinetic energy in nth orbit is equal to m e raised to 4 8 epsilon 0 square h square n square. This is the expression for kinetic energy for nth orbit. But for the first orbit, kinetic energy in first orbit is equal to m e raised to 4 8 epsilon 0 square h square. Because value of n is equal to 1, means n square is 1, and that's why kinetic energy is equal to this. See here, total energy equal to minus m e raised to 4 8 epsilon 0 square h square. What is the difference? Total energy is negative and kinetic energy is positive. Therefore, m e raised to 4 8 epsilon 0 h square, here is negative sign, remove this, kinetic energy must be equal to 13.6 electron volt. This is the value of the kinetic energy. Means this is actually the first point which is to be found out. The next one, find out the potential energy. Again, the expression for potential energy is equal to minus m e raised to 4, here is 4 epsilon 0 square, here is h square n square. This is the expression for potential energy. But that must be equal to multiply by here is 2 and divide by 2. Means minus 2m e raised to 4 divided by 8 epsilon 0 square h square n square. This is expression for potential energy in nth orbit. But for the first orbit, potential energy in first orbit is equal to, n is equal to 1, means minus 2 m e raised to 4 8 epsilon 0 square h square, that must be equal to minus 2 multiplied by m e raised to 4 8 epsilon 0 square h square. M e raised to 4 8 epsilon 0 square h square. What is this? This is kinetic energy, and that must be equal to minus 2 multiplied by 13.6. 13.6 multiplied by 2 means 27.2 with negative sign electron volt. This is actually the value of the potential energy in the ground state. Means this is actually the solution for the problem first. Energy is given in ground state, total energy, and from that kinetic energy and potential energy is found. Okay, the next problem. Next problem, the radius of the first Bohr orbit is 0.52 astronomy. Calculate radius of third Bohr orbit. Again, read the problem carefully and decide what is given. Again here, radius of the first orbit is given, means that is r1. r1 is equal to 0.52 astronomy, and for first orbit it is, we suppose n1 is equal to 1. And for third orbit n3 is equal to 3, and we want to find the radius in third orbit. What is given? Radius of the first orbit is given, and we want to find the radius in third orbit. Again, we know the formula for the radius of the hydrogen, radius of the electron in hydrogen atom, and that formula must be equal to, again we know Rn is equal to epsilon 0 square h square n square divided by pi m e square. This is actually the expression for the radius of the electron in nth orbit. But in this equation, epsilon 0, permittivity of free phase, is constant. What is h? H is Planck constant, again it is constant. Pi is constant. M, mass of the electron, is constant, and E, charge of the electron, is. All these terms are constant. Therefore, we write Rn is equal to, in bracket, epsilon 0 h square divided by pi m e square multiplied by n square. All these terms in the bracket are constant. Therefore, radius in nth orbit is directly proportional to square of principal quantum number. And use this formula for finding the radius in third orbit. From this formula, there is R3 divided by R1, that must be equal to, there is N3 square divided by N1 square, that must be equal to. What is N3 is 3, its square is 9 divided by 1. Then R3 is equal to 9 multiplied by R1. There is 9 multiplied by R1. What is the value of R1? 0.5. Multiply this 9 multiplied by these 2, that is 18. 1, 45, there is 4, 6. Means 4.68 astronomy. This is actually the radius in third orbit. Radius in third orbit. Remember this. This is actually the solution for the second problem. Next problem. The period of revolution of electron in third Bohr orbit in hydrogen atom is 4.132 into 10 raised to minus 15 second. Means third orbit period of revolution is given. Find the period of revolution of electron in fourth orbit. Again, read the problem carefully and decide which things are given. Here is given period of revolution in third orbit is given, means T3 is given 4.132 into 10 raised to minus 15 hertz. For third orbit means N3 is equal to 3. And we want to find the period of revolution of electron in fourth orbit means T4. And for T4, N4 is equal to 4. This is actually the given. For finding the period of revolution in fourth orbit, we know the relation for the frequency of revolution in nth orbit. And that frequency of revolution, that is Fn, is equal to, what is this expression? M e raised to 4 divided by, then the next value 4 epsilon 0 square h cube n cube. This is the expression for the frequency of revolution in nth orbit. From this equation, we know that period in nth orbit is a reciprocal of the frequency. Therefore, period in nth orbit is equal to, here is 4 epsilon 0 square h cube divided by, again here is multiplied by n cube, and here is m e raised to 4. From this equation, see, epsilon 0 permittivity of free phase is constant. Here is h cube, h, again like constant. M is constant, mass of the electron, and E, charge on the electron, is constant. All these terms in the bracket are constant, therefore we can write period in nth orbit is directly proportional to the cube in the cube of the principal quantum number. We get this relation. Therefore, from this equation, we write the equation here is T4 divided by T3 is equal to, T4 means here is N4 cube divided by here is N3 cube. That must be equal to, what is the value of N4? N4 is equal to 4. And the cube of the 4 is, here is 64 divided by, N3 value is 3, its cube is 27, means T4 is equal to 64 divided by 27 multiplied by T3. This is actually the expression for T4. That must be equal to 64 divided by 27 multiplied by, what is the value of T3? Value of T3 is given 4.132 into 10 raised to minus, it is 50. This is actually the value. Such type of calculation up to the 12th calculator is not allowed. And such type of calculation can be found out by using the logarithm. But at FY level, calculator is allowed, and that's why we can solve this by using logarithm table or by using the calculator. And after solving this, the value of T4 must be equal to, and that value must be equal to 9.7, it is 94 multiplied by 10 raised to minus 15 second. This is actually the final answer. This is actually the final answer. Means solve this by using the log table or by using the calculator and we get this answer. Okay. The next problem. Find the ratio of radius of third Bohr orbit to radius of the first Bohr orbit. Means for first Bohr orbit n1 is equal to 1 and for third Bohr orbit n3 is equal to 3. And what is to be find out? Find out the ratio of R3 upon R1. Find out this ratio. In previous problem we already considered radius in nth orbit means Rn is directly proportional to square of principal quantum number. We already considered this. And from this equation R3 divided by R1 is equal to is n3 square divided by n1 square. Therefore, R3 divided by R1 is equal to, what is the value of n3? Is 3, its square is 9 and it is value of n1 is 1, 9 upon 1. Means the ratio R3 upon R1 is equal to 9:1. This is final answer. R3 by R1 is equal to 9:1. This is actually the problem number 4, solution of the problem number 4. Next problem. Calculate the frequency of the electron in Bohr's first orbit of hydrogen atom. Means we want to find the frequency of revolution in the first orbit. Given n is equal to 1. This is actually the, and we want to find the frequency in first orbit. For when we use this, for finding the frequency of revolution, we know the formula for frequency in nth orbit, Fn is equal to, what is that formula? m e raised to 4 epsilon 0 square, there is h cube and n cube. This is the formula. Means m e raised to 4 epsilon 0 square h cube. But for first orbit, the value of n is equal to 1. Therefore, F1 is equal to m e raised to 4 divided by 4 epsilon 0 square h cube. N is 1, its cube is 1. Therefore, F1 is equal to this. Therefore, F1 is equal to, what is m? Mass of the electron is given, no need to remember, and that value must be equal to 9.1 multiplied by 10 raised to minus 34 kg. This is the value of the mass of electron. Then each charge of the electron is multiplied by 1.6 multiplied by 10 raised to minus 19 coulomb. Its power is 4 divided by H. F1 is equal to this 4 multiplied by epsilon 0, permittivity of free phase, and what about its value? Permittivity square, 8.85 multiplied by 10 raised to minus 12, its square is square. What about the H? H is Planck constant. What is its value? 6.6. Its value is 6.623 multiplied by 10 raised to minus 34 cube, H cube. This is actually the substitutions. After substituting all these values and calculating by using the calculator, The value comes out to be 6.54 multiplied by 10 raised to 15 hertz. And this is final answer. Remember this, when such type of problem asked, all these terms are given. Mass of the electron is given, charge on the electron is given, permittivity of free space is given, and Planck constant is given. Substitute all these values and calculate by using the calculator and simplify, we get the answer. Frequency of revolution of the electron in Bohr's first orbit, that must be equal to 6.54 into 10 raised to 15 hertz. This is actually the value. Okay. Next problem. Problem number 6. Calculate the change in angular momentum of electron when it jumps from third orbit to first orbit. It is third orbit to first orbit. Third orbit means, again, what is given? Third orbit n3 is equal to, that is 3, and first orbit n1 is equal to 1. It jumps from third orbit to first, means higher orbit to lower orbit. When the transition takes place, and during this transition, angular momentum changes. And we want to find the change in angular momentum, del L. We know the formula for the angular momentum. According to Bohr's second postulates, angular momentum is an integral multiple of h upon tau square, and therefore angular momentum is equal to n multiplied by h upon tau square. This is actually the formula. Angular momentum for third orbit, we call it as a L3, that must be equal to, and for third orbit it is n3 and that value must be equal to 3. 3h divided by tau square, all this is first. And angular momentum in first orbit, we call it as a L1, and for that n1 is equal to 1, substitute n value is 1, it is h upon tau square. Call this equation second. When electron jumps from third orbit to first orbit, there is a change in angular momentum. And change in angular momentum, that must be equal to L3 minus L1. What is the value of L3? It is 3h upon tau square minus L1, it is h upon tau square. It is 3h minus h, it is 2h divided by 2 pi. It is 2 gets cancelled, that must be equal to h upon pi. What is the value of h? What is Planck constant? That value must be equal to, that is actually the 6.63 into 10 raised to minus 34. And what is the value of pi? 3.14. When we solve this, we get 2.11 multiplied by 10 raised to minus 34 joule second, and this is actually the change in angular momentum when electron jumps from higher orbit to lower orbit. This is actually the expression for the problem number 6. It's very simple concept. Electron when jumps from higher orbit to lower orbit, what is the value of the angular momentum in higher orbit and what is the value of angular momentum in lower orbit? Subtract higher orbit minus lower orbit, and we get this expression. This is actually the change in angular momentum. Next problem. Compare the linear velocities of the electron which are revolving in fifth and third orbit. Here we want to compare the linear velocity of the electron revolving in fifth and third orbit. Means what is given? Orbit number 3, n3 is equal to 3, and orbit number 5, n5 is equal to 5. And we want to compare the velocities of electron in fifth orbit to third orbit. This is actually the situation. Before comparing this, we must know what is the expression for the velocity in nth orbit, and that velocity must be, we know the equation, velocity in nth orbit is equal to E square 2 epsilon 0 h into n. This is the expression for the velocity in nth orbit. Again, you remember that in this equation Vn is equal to E square 2 epsilon 0 h multiplied by 1 upon n. All the terms in the bracket are constant. Means velocity in nth orbit is inversely proportional to the principle of quantum number. Principle of quantum number. This is actually the main equation. And from this equation, how will you write? V5 divided by V3 is equal to, means it is N3 divided by N5, because relation is inversely proportional. What is the value of N3? N3 is 3. And what is the value of N5? That value is 5. That must be equal to 0.6. And what is actually the final expression? V5 divided by V3 is equal to 0.6 is to 1. This is actually the answer for this problem. Very simple. Remember this very important. Velocity is inversely proportional to principal quantum number. This is very important equation. From that we can find this solution. The next problem. The potential energy of an electron in second orbit of hydrogen atom is given. Means potential energy in second orbit is given, and that value is minus 6.8 electron volt. This is the value. Compute the kinetic energy, potential energy and total energy of the electron in the fourth orbit. Means kinetic energy in fourth orbit, potential energy in fourth orbit and total energy in the fourth orbit. These are actually the things we want to find out. Before finding this, we know the expression for the potential energy. Potential energy in nth orbit is equal to minus m e raised to 4 epsilon 0 square, it is h square multiplied by n square. This is the expression for the potential energy. Again, potential energy in second orbit is given. Means potential energy in second orbit is equal to minus m e raised to 4. Value of n for second orbit, that is n is equal to 2. 2 square is 4. 4 multiplied by 4. It is 16 epsilon 0 square h square. And this value is given, and that value must be equal to minus 6.8 electron volt. Remember this. Potential म्हणजे m e raised to minus m e raised to 4, 16 epsilon 0 square h square is equal to minus 6.8 electron volt. This is given, and we want to find the kinetic energy, potential energy and total energy in the fourth orbit. This equation is very important. Remember this. Again, kinetic energy is equal to, what is the expression for kinetic energy? M e raised to 4 8 epsilon 0 square h square multiplied by n square for nth orbit. But for fourth orbit point of view, it is m e raised to 4 8 epsilon 0 square h square. What is the value of n? N is equal to 4. 4 multiplied 4 square, it is 16. That must be equal to 1 upon 8 multiplied by m e raised to 4, here is 16 epsilon 0 square h square. M e raised to 4, 16 epsilon 0 square h square. Here is negative sign, here is negative sign. Don't worry about that negative sign. M e raised to 4, 16 epsilon 0 square h square is equal to 6.8. Means 6.8 divided by 8. And how will you find out this? 6.8 divided by 8. Here is 0. Here is 85 electron volt. This is the value of the kinetic energy in fourth orbit. Kinetic energy in fourth orbit. Next one, potential energy. Expression for potential energy in fourth orbit, that must be equal to, according to this, minus m e raised to 4 divided by is 4 epsilon 0 square h square. Again, what is the value of n? N is equal to 4. Means again a is a 16. That must be equal to 1 upon 4 in bracket minus m e raised to 4 16 epsilon 0 square h square. And what is the value of minus m e raised to 4 16 epsilon 0 h square? Minus 6.8. Means potential energy in fourth orbit is equal to, it is the value of minus 6.8 divided by 4. That must be equal to, it is minus 1 and that is 7. Minus 1.7 electron volt. This is the value. What about the total energy? Total energy in nth orbit minus m e raised to 4 8 epsilon 0 square h square n square. That must be equal to total energy in fourth orbit minus m e raised to 4 8 epsilon 0 square h square. What is the value of n is 4? Means 8 is 60. That must be equal to 1 upon 8 in bracket minus m e raised to 4. Here is epsilon 0 square 16 epsilon 0 square h square. What is this value? Minus 6.8. Minus 6.8 divided by 8, that value is minus 0.85 electron volt. This is a value of the total energy. In this way, from the potential energy in second orbit, we find the kinetic energy in fourth orbit, potential energy in the fourth orbit, and total energy in the fourth orbit. This is today we see the problems on the Bohr's theory or Bohr's postulates. Expression for kinetic energy, potential energy, total energy, radius of the nth orbit, all these terms are considered here. Next time we will see the problem on Bohr formula and energy level diagram. Today I will stop here. Okay, thank you.